Hey guys, this is just a continuation of yesterday. Sorry I'm out. My wife has another doctor's appointment follow up. Anyway, I'll miss you guys, but I just want to show you real quick. What we're going to do is we're going to take something that's in standard form, like a quadratic in standard form, and we're going to change it to vertex form. And the way that you do this is by completing the square like we were doing yesterday. So basically what you're going to do is you're going to rewrite this. So we're going to do x squared plus 6x, and then we're going to be adding something. And then we have the 17 from right here. And then we're going to be, since we added something on the right side of the equation here, we're adding here, we're also going to subtract the same amount. Now this seems really weird. Why would we do that? Well, the reason that we're doing that is because when you add it and you subtract it on the same side, this entire expression here is still equivalent to what it was before, which is what we want, right? Like we want the same thing, we just want it to look different. And so what we're going to do is we're going to do the exact same thing that we did yesterday. We're going to complete the square. So what I want you to do is I want you to focus on the x squared plus 6x, right? So just like yesterday, when we had x squared plus 6x, you imagine the box. Here's your x, here's your x, here's your x squared. And then you take half of that 6x, which is 3x, and you can make these little rectangles here, right? Which means that the side length here is 3, this side length here is 3. And that means you're going to be adding on, to complete the square here, you're going to have a 3 by 3 box. So you're going to be adding 9, okay? So you're going to add 9 there. You're going to subtract 9 from the same side. And then what happens here is this whole yellow thing is now a perfect square, right? That's the whole reason for completing the square, was to make sure that this yellow thing condenses down into the same yellow thing right here. Okay, so what would this be, like x squared plus 6x plus 9? What do you have to square in order to get x squared plus 6x plus 9? You would have to take x plus 3 and square it, right? That's what that is up here. So that condenses down into x plus 3 squared, and then you still have plus 17 minus 9. So 17 minus 9, that would be 8. And this is vertex form. So let's read the directions here. Complete the square to put it into vertex form. So we're in vertex form there. Once in vertex form, convert back to standard form to check your answer. So the vertex here, on the homework it asks you to list the vertex. The vertex here would be at negative 3, comma 8, right? Because this moves us left 3, up 8. So that's our vertex. And then all we're going to do is we're going to take x plus 3 and actually multiply it by itself. So we're going to take x plus 3 squared plus 8. And we're just going to double check and make sure that this actually comes back to what we started with. So when you do this, you'd have x squared plus 3x plus 3x plus 9 plus 8, which is x squared plus 6x plus 17, which is what we started with. Okay? So that's the basic idea. There are a couple weird, tricky things that I'm going to show you right now. But that's the basic idea. So I don't think super difficult here. So, okay, so on this one, what's annoying about this one is you have a 2 here. So how do we deal with the 2? So you've got y equals 2. So what we're going to do is we're going to factor this 2 out of these two terms here. So we're going to kind of leave the 8 alone over here. So we're leaving the 8 alone. And what we're going to do is we're going to factor that 2 out. So we got x squared plus 6x, right? And if you're not sure if you factored it correctly, you can just check the 2, distribute it in, and you should end up with what you have up here, which we do, right? If you multiply this 2 and you get 2x squared plus 12x plus 8, okay? So you factor the 2 out. Now what we're going to do is we're going to complete the square inside of the parentheses here. Okay, so we're gonna add something on the inside and we're gonna subtract on the outside. Okay, so and this is I did this on purpose. This is exactly the same square scenario as the last one, but it's gonna end up a little different here. Okay, so what's gonna happen here is we're still gonna be adding 9, right? If you take half of 6, which is 3, and then you multiply that by itself, you square it, that's gonna be 9. But this is what really confuses people. I want you to think about this very carefully. Are we actually adding 9 right here? No. Why not? You see the 2 out here? We're actually adding 2 times 9, right? Because that 2 is getting distributed to the 9. Now, look, I mean, we literally wrote 9 here, right? I'm not saying we didn't write a 9 there. But by multiplying, because you have this 2 out in front, and because you're putting a 9 right here, you're actually adding 18. So when you subtract over here, just make sure that you compensate for what you actually added right here. Okay, so we actually added 18, which means we need to subtract 18. So in general, whatever you have out in front here and whatever you choose to add here, just make sure you subtract this times this. Okay, so and we'll do another example. So we got this. So what does this condense down into now? So we have y equals, you have a 2. This whole trinomial expression here condenses down into x plus 3 squared. And then 8 minus 18 would be minus 10. Okay? So, and then the vertex here would be at -3, -10. Notice it also has a stretch by a factor of 2. Not that that really matters for this problem, but and then if you want to check this, you can write it out: x plus 3 times x plus 3 minus 10. And then what I would do on this is I would actually multiply the x plus 3 squared first. So I would do x squared plus 3x plus 3x plus 9. Okay, so I'm multiplying this part out first. Minus 10. And then you can distribute the 2 here. So 2x squared plus 6x plus 6x plus 18 minus 10. So 2x squared plus 12x plus 8, right? And is that what we started with? It is. Yeah, perfect. So that one works. Okay? All right. Let's do another example here. So exact same idea here. So we're going to take this part, we're going to pull this 4 out. So we're going to have, after we factor the 4 out, you're going to have x squared minus 10x plus 26. The 10 comes from taking 40 and dividing by 4. Okay? And then we're going to do y equals 4. We'll have x squared minus 10x, and we're going to be adding something here to complete the square, plus 26. And then we're going to be subtracting something to compensate for that. So if you imagine our scenario, right? So you have your square here. You got x, that makes x squared. And then you got to get negative 10x. So I'm going to put negative 5x for both of these rectangles, which means that this guy right here is negative 5. This guy right here is negative 5. So how much are we adding on by completing the square here? It's going to be negative 5 times negative 5. So we're going to be adding 25 there. Okay. Now, are we actually adding 25 by putting a 25 here? No, we're adding 4 times 25. So we're actually adding 100. So in order to compensate for adding 100, we're going to subtract 100. And so your final vertex form here would be 4. What does this condense down into? This is x. It's right over here. It's x minus 5. Okay, so x minus 5 squared. And then, let's see, 26 minus 100, what is that, negative 74? I hope that's right. I'm doing that in my head. Okay, all right, that's example 3. And then we got one last example here. What do you do with a negative number? So with a negative number, go ahead and pull out the negative 2 out of this. So when you do that, you'll get x squared. And be really careful here. If you take this and divide by negative 2, 16x divided by negative 2, that's going to give you negative 8x. Okay, so minus 8x. Okay, and then plus 12. So we'll have y equals negative 2, and then x squared minus 8x plus something, plus 12, and then minus something to compensate. Okay, so just real quick, a little trick, right? So you can just take half of this number, half of negative 8, which would be negative 4. You can square it. So what's negative 4 squared? That would be negative 4 times negative 4, which means we're going to be adding 16. And here's a really weird scenario. You're having negative 2 times 16. So what are you doing here? you're actually, for this part of the problem, you're actually subtracting 32, right? Because you have negative 2 times positive 16. So again, we just need to compensate for what we're doing here. So if we're actually subtracting 32, then I think over here, we should be adding 32 to compensate for whatever we did there. Okay, so you got negative 2. This will condense down into x minus 4 squared. By the way, how do I know that it's x minus 4 here? It's always just whatever half of this was. You'll have x, minus or plus that. You can also draw the picture and see that it works that way. Plus, and then 12 plus 32 would give you 44. Okay, and if you multiply this out, you would see that it does work. Okay, so all right. Well, hopefully that was helpful. If that was not helpful, I don't think there's a Khan Academy. So ask your friend. If you're in 8th, 9th period, ask Jack. If you're in 12th period, ask Caroline. She'll probably help you out. Anyway, all right. Have a good break, guys. I will see you guys on Tuesday next week.